So the next section is similarity and dissimilarity. I'm going to kind of blast through similarity and dissimilarity to get to data exploration and visualization. If we have to cut data exploration and visualization a little short, we will, because we're going to talk about it a lot on, I think it's Tuesday when we do, on Monday when we do the introduction to uh, lab webinar. So similarity and dissimilarity are exactly what they sound like. Similarity is a numerical measure of how alike two data objects are. It is higher when objects are more alike, and you usually set it up so that it falls in the range between 0 and 1. Dissimilarity is a numerical measure of how different two data objects are. It's lower when objects are more alike. The minimum dissimilarity is 0 almost always. The upper limit varies based on the exact metric you're using, but is often 1, just sometimes higher. And we'll use the term proximity to refer to either how similar or how dissimilar objects are. So objects that are close will have a high similarity or a low dissimilarity. And if objects are far, if they have a low similarity and a high dissimilarity. Now, in the context of data matrices, of very nice numeric data, we can use something very straightforward. We can use simple distance formulas. But in the context of categorical data, nominal or ordinal data, then we often need to use different things. So nominal data, we usually use this sort of binary similarity-dissimilarity measurement, where dissimilarity for nominal is 0 if the two values are the same, and 1 if the two values are different, and exactly the reverse for similarity. For ordinal values, for dissimilarity, we'll often map our values to our integers from 0 to n minus 1, and then take the difference in those integer values and divide by the maximum, giving us a nice measurement between 0 and 1. And similarity, we take 1 minus the dissimilarity measurement. So that's really the reason why I'm talking about similarity and dissimilarity separately, rather than just sort of talking about one of them, is that there are some data types, like say nominal data types, where similarity is a very natural measurement. It's 1 if the two are the same, and 0 if the values are not the same. Whereas for something like ordinal variables, the measure of dissimilarity is kind of an easier and more natural way to think about it. We think about how far apart the variables are, not how close together they are. And similar for interval or ratio variables, we'll often just take the absolute difference between the variables as a measure of dissimilarity, and then we might do some slightly more complicated things to calculate a similarity.